The Chicago Temple needs an overhaul. As far as the occupants and the ownership is concerned, they'd like to bring the building up to a Class A or close to a Class A building.
Well, basically the challenge was to come up with a piece of equipment to meet the engineer's design to supply with a single unit the entire Chicago Temple structure.
One of the other unique things about the Chicago Temple project is the team approach that's existed from the start, and in particular on this phase of the project for the HVAC system.
We got a lot of eyes on us today, okay? You all know this is the biggest air handler that's ever been built, a modular like this, okay? So let's have a good, safe lift.
The way you start is usually the way you finish. This job started perfectly and it ended perfectly. You couldn't ask for any better.
One of the responsibilities of being a church in the middle of the city is being the best stewards as you can with the facility that you've got. Now, this is an extraordinary building, the Chicago Temple building. It's the fifth Methodist church on this corner. The first one was a log cabin back in the 1830s, and that was torn down, and they built a church that looked like a church. That was torn down, and they, in 1854, built a church that was multi-purpose so that there was commerce on the first two floors and the church on the top two. That burned in the Chicago fire. They replaced it, and then in the 1920s, they built this, which was an extraordinary elaboration on the mixed-use idea. So we have church on the first few floors. We have 15 floors of offices that are rented primarily to lawyers because we're across the street from the courthouse. Clarence Darrow had his office in this building in the 1930s. And then in the steeple, there's a residence and also a chapel. This is the Dixon Chapel. It's kind of a side chapel here on the second floor, and every Saturday evening we have worship services in here. We're in the basement of the church, what we call Pierce Hall. This is an area that we restored about 4 years ago. It was a very dark and damp church basement. Once we started fixing the water problems, we kept going, and eventually we ended up with a very useful social hall here that also is a theater. This being the church, the main thing that we do that distinguishes us from all other groupings is we worship a lot in this setting. So this is our main setting as the sanctuary. This is really the heart of the ministry of the church, and it's probably the most surprising part of the building because when people walk in, they really don't expect to find a large and very quiet sanctuary in the middle of the city. The stained glass windows are backlit because we don't actually have any outside lighting in this part of the building. And most of it is very traditional Christian iconography, but there's one window on the west side that is kind of fun because it shows the Chicago River and the tall buildings that are around the Chicago River. And if you look just off to the right part of that panel, you'll see the Chicago Temple there. Now, we're actually not that close to the river, but obviously the person doing the stained glass knew who was paying for it, made sure that we got into the picture. We're in the Sky Chapel, which is the highest point of worship above street level in the world, says the Guinness Book of World Records. Though we don't worry too much about that. You put 15 floors of lawyers in between the downstairs and the upstairs part of the church, you're going to win some distinction. But what's important is this is the old bell tower that about 25 years after the church was built, they abandoned the bells, and Mrs. Walgreen of the drugstore family gave the money to turn this into a prayer chapel. It was opened on Easter morning of 1952, and we still use it for Easter morning services. Every Thursday after work, we have an evening prayer service. So we have this altar up here that is a companion to the one down in the sanctuary, and up here it is Jesus looking over Chicago. 1952, and if you look carefully, you see a couple of distinct buildings, the Tribune Tower, the Wrigley Building, the Jewelers Building. These are all part of the skyline of 1952. We feel it is really important to maintain the facility, not only so that it's pretty, but also so that it's safe and also so it's efficient. How do we save resources and how do we become a good steward in the middle of the city in terms of things like how do we fit into the city's expectations of buildings becoming green?
The Chicago Temple needs an overhaul. As far as the occupants and the ownership is concerned, they'd like to bring the building up to a Class A or close to a Class A building. The building was built in the 1920s. The infrastructure is inadequate for today's needs, for teledata, ventilation, power. They suffer with inadequate power to distribute around the building. They've patched systems together, jumped from floor to floor to pick up services. So the building is in need of a complete gut and upgrade.
We started work probably about 4 years ago on the Chicago Temple building when we were charged with developing a capital improvement program for the building that would respond to their goal to be a Class A building. The building had gradually over a number of years fallen into some obsolescence in certain areas. It was still a prime building. It's a wonderful location and it's a wonderful building. But particularly on the mechanical systems and many of the infrastructure systems, they were dated and really weren't working properly. It was getting harder to maintain them, operate them efficiently, and so forth.
I think that the message for green buildings has been talked about for quite some time now, and I think it's now in the past few years that the message is being conveyed in the proper manner, and people are starting to understand that there is owner benefits, you can save costs on operating equipment, you can actually increase the quality of life inside the building, you can also increase productivity for your companies. So there's a lot that comes into play, and I think people are finally starting to get that message.
I think it's a great effort for lots of reasons. The mission is good for the earth, good for the environment. And I think a lot of people can get on that kind of bandwagon. It's an easy thing to promote, but to do it smartly, to actually design equipment and building systems that are efficient, commission the building so that they are run efficient, and then hopefully prove that the return on investment, is there too for the owner. The unit that we're building, which is made up of 22 pieces, is not your standard air handling unit. It is a custom unit from Raycan. It has variable frequency drives. The system will work in tandem. It's basically a pair of air handling units built as one unit. All the piping will come into it from the middle, and it's piped to the coils within itself. The unit is very efficient. We'll be able to operate this through a building management system that will run the unit just to meet the load and not any more than that. So it will run at its peak performance most of the time.
This is the largest piece of equipment that I've been involved with. In fact, I could safely say it's the largest piece of equipment that Temperature Equipment Corporation has been involved with. I've been with them since October of 1974, and I've never seen anything remotely close to the size of this thing. It became so big because it had to be one single unit. There are 4 75 horsepower supply fan motors and 4 25 horsepower return fan motors. It'll handle about 900 tons of air conditioning. I suppose if you want to equate it to how much that is, that's enough to do about 300 average homes. So, it has to have enough fan capacity to move 235,000 cubic feet of air per minute through the building for the heating, ventilating, and air conditioning.
Every once in a while, there's a very specific project which can't be met by this type of equipment, and that's where Raycan comes in. We had to fit this equipment into an extremely small footprint on the roof of this building, the Chicago Temple, and we also had to make sure that this equipment was deliverable. Okay, so it was engineered into several pieces. each one designed to fit specifically on a flatbed or a drop deck truck, and delivered here to Chicago in sequence.
This is an enormous undertaking for any contractor to have to lift a unit or sections of a unit 23 stories above a major street and then install it and rig it in place. We're dealing with a system that is very, very high. It is a double-stacked air handling unit that's moving 235,000 cubic feet per minute of air. These were the bigger challenges that we were faced at Raycan when designing the modules and ensuring that we had modules that didn't exceed the crane lifting capacity, which was about 16,500 pounds. It will look like a two-story condo, effectively. If we looked at its overall square footage, it's about 3,700 square feet of living space. Although nobody will live in it, they'll be using it for, or accessing it for maintenance purposes. The system is 47 feet wide by 37 feet long and is 22 feet high.
How we came to that unique piece of equipment, we have used, and I have used Raycan in the past. I've been to their factory. They produce a great piece of equipment. It's a very solid, well-made, high-quality piece of equipment. And we know we can put that up there and feel good about its life cycle costs. Our end game, too, is to prove that, the building's efficient and it's going to save money. And we need to be sensitive, too, that it's an easy building to operate when we're done. It's not complicated. So this piece of equipment will do that.
The challenges that we really faced were in incorporating this in the building in a manner that it didn't detract from the original character of the building. And so we were able to do that. Fortunately, we were dealing with the building that has some unique features that helped us in this. At the north end of the building is a tower. Most of this equipment is being installed directly south of that, so it'll be hidden from the main views to the north. In taking a look at it and doing computer studies of the building, you're only going to be able to see a very narrow sliver of this from anywhere on the street. Otherwise, you won't see it at all. We've also got a large riser duct. It's somewhere in the neighborhood of 15, 16 feet square. It's going to come down in a recess on the east side of the building. That'll also be hidden and clad in a limestone type material so that it'll look basically like the rest of the building.
Some of the special challenges that we had on this project, again, is due to the fact that this building is 95% occupied. So we need to make sure we do our job, we do it right, and we don't get in trouble. Part of that is building a completely independent system, sort of like the Pompidou in France, where all the systems are outside the building.
Well, basically, the challenge was to come up with a piece of equipment to meet the engineer's design to supply with a single unit the entire Chicago Temple structure, both heating and cooling and ventilating, in a single piece of equipment, and also one that would be suitable for outdoor usage.
Our engineers worked very closely with the engineers at DBHMS to make sure that this equipment could be built on site in an extremely compressed schedule. Basically, we had 24 hours to build the entire 22 sections of this air handler. Put that in contrast, we usually take about 24 hours for a very simple straight-through air handler of 8 or 9 sections. What that meant is that we had absolutely zero tolerance for error.
The weight was a very, very significant consideration. The unit itself, in total, once installed on the roof, is going to weigh 222,000 pounds. So we had to ensure that the roof could sustain that kind of distributed load and that effectively each module would not exceed the crane capacity, which was 16,500 pounds on lift. It arrived here in 15 trucks. They were flatbed trucks that were designed to handle wide load. It had to travel over a 4 to 5 day period from Montreal to Chicago during daylight hours only because of the wide load nature of it. They can't ride at night. And all of those trucks needed to be staged in an order and in a sequence so they could be effectively lifted onto the roof in the proper sequence for the contractors.
Well, every vendor that we dealt with, we had done business with before. Number one, the equipment was supplied by Carrier Corporation, their Raycan division. The company that supplied the crane, Stevenson Crane, we'd worked with them many times before. They were in on numerous meetings prior to this, big lift taking place. We took other bids from other vendors for this unit, and Carrier we felt was the best bid. Hill was also responsible for all the structural steel for this unit, which weighed a tremendous amount of weight. And everything had to be, fit together because the structural had to meet up with the unit.
One of the other unique things about the Chicago Temple project is the team approach that's existed from the start, and in particular on this phase of the project for the HVAC system, where the architects, the engineers, and the contractors and equipment suppliers have all worked in concert and in a cooperative way to find the best solution for this project.
This project brought together a number of consultants, HPZS, the architect, they are also structural engineers, perfect for the job. As we have up on the roof, you'll see a structural platform that holds the entire equipment here. That was pre-engineered by HPZS. Hill Mechanical, super company. They've basically organized and coordinated the dance today.
Bruce brought me into the project early on when the project was under design by DBHMS. Bruce came to us and asked us if we could build a piece of equipment to comply with the requirements by DBHMS. I took those requirements to Raycan and Montreal, Carrier Raycan, and they came up with a preliminary design. And the engineer said as long as we can basically fit on the footprint in the space allocated for the project, that the Carrier Raycan unit would be acceptable. So with that, Bruce had us pursue this and get a complete design from Raycan.
Well, we worked very closely with the engineering company, DBHMS, on this job. They're based here in Chicago. Basically, this project was a challenge of form, fit, and function. DBHMS defines the function, and then we work together very closely to define the form and the fit.
This weekend coming up for the lift itself, there will be a lot of activity. Hill Mechanical has done a great job organizing the lift itself. There's a huge amount of effort in coordinating the trucks, the delivery of the trucks, the delivery of the equipment sequenced so that it gets built in reverse from a finished product. I think there are going to be 31 picks from the trucks as well as the crane. There's a lot of different players on this, from the crane company, Hill Mechanical. We'll be there to observe basically the action, but our primary concern is the equipment gets placed correctly, gets bolted down, and that it's intact and operational when it's finished. But in the meantime, there will be a lot of different players. The steel structural people will be there, making sure that the equipment dovetails with their equipment. There are going to be welders there on site to weld the equipment in place as the pieces come together. Because when they leave, it has to be secure. If we get a wind on Monday, it better still be there. So we have to build this thing intact, bolt it down, and make sure it's secure.
Today we're at the crane lot picking up these units for our big lift on Saturday. We're taking them down into the city to a staging lot that's like 1.5 miles from the job site. Hi, my name's Russ Murphy. I'm the logistics manager for Hill Mechanical. I handle all of the trucking and permitting and making sure everything gets there safely and legally. Today we're at the crane lot picking up these units for our big lift on Saturday. We're taking them down into the city to a staging lot that's like 1.5 miles from the job site. This way on Saturday we don't have any issues running on the highways. Everything's good to go.
My name's Mike Denzi. I work for Hill Mechanical, and we're kind of loading up these units on the trucks, prep them for a crane lift on a roof.
This is the Windy City. Everything changes at a moment. There's one thing that's for sure. It could turn on us, but if it gets too dangerous, we'll have to call it off. It's all about safety. We can't risk anyone's life. If it should catch wind or anything like that, we need to determine that if it's safe or not for us to go.
All right, what we're doing now is this deck height on this trailer is a little higher than I'd like, so we're just gonna throw an actual tape on it, just to see where we're at, to see if we're legal or not. If we're not legal, we're gonna have to call the state and get an overheight permit, which isn't a big deal, but we gotta do this the right way so we don't mess up. So, Jeff? Where are we at?
We're at 1311.
1311. All right, we're at 1311, so that's putting us about 5 inches over legal height. So that's what we're gonna have to do. We'll call the state, get a new route, get a new permit, check all our bridges, and it'll be a go from there. That's it.
Country boy, his X factor. It ain't how we roll that gets you where you want to go. It ain't the horse, it ain't the barn that keeps you coming back to the farm for a little more. E-I-E-I-O. It ain't the grits, it's that slow southern drawl calling you baby.
The crane itself will arrive in probably 5, 6, 8, 10 flatbeds of parts for the crane. And then they put it all together and then we're ready to go. From what I understand, it's about $50,000 a day to shut down the street. Because yesterday they looked into seeing if we could start setting the crane up earlier, Friday night at like 8 o'clock, and they said not a problem, but that constitutes another day. It's $50,000 more. So we chose to just go with our original plan starting at midnight. It does take about 8 to 9 hours to build the crane on site because it's a huge crane. The crane itself will arrive in probably 5, 6, 8, 10 flatbeds of parts for the crane. And then they put it all together and then we're ready to go.
This will go 24 hours a day till we're done. Hopefully we won't be impeded by any bad weather.
My name is Mike Lafferty. I'm with Altus Traffic Management. And today on the project, we'll be controlling the traffic coming across the lift. We'll be stopping the traffic on the left where the trucks will be coming in with all the air conditioning equipment. And we'll be stopping the traffic at the north so that the trucks can back in underneath the crane so that they can lift the equipment off of the trailers. We also have to keep all the pedestrians off of the walkways where the lift is going overhead. This is a 2.5-day project that this road will be shut down the whole time. These 2 roads are shut down temporarily while we're bringing in the equipment and we have it closed off.
This will go 24 hours a day till we're done. Hopefully we won't be impeded by any bad weather, wind, or any of that, or problems with the customer up on the roof having any problems getting their equipment together. The top of the building is 287 feet. And what you got to look at is we're not too far away from the building. We're only about 65 feet from where the center line of the crane is to the edge of the building. Now what comes into play is we can extend the boom out, but we have to take in consideration how far we got to, in on the roof, and we take it on an angle because we would never get the job done if we were directly in front of the building. So you've got problems with elevation of the building you're going to try to clear, street lights, other obstructions you got to pay attention to while you're trying to set this crane up.
Take and go from this one to this one, and then there'll be two hooked up to this one, and then from that backside, like an M&M arch.
Roof crew. I know you guys aren't on the roof, but I want you to understand what these guys are dealing with, okay? I discussed 285 feet in the air plus another 25 feet of steel in units, okay? These guys have to be very, very cautious up there. They're all going to be tied off, 100% tied off at all times. So again, afford them the time that they need to do the job, okay?
That was a safety meeting that we had, and when you have a job of this size with this many people working that close to the edge of a 22-story drop-off, we like to have a good safety meeting and make sure that everybody understands exactly what their job is. They understand the proper use of the safety equipment that they've been equipped with, and to pull this thing off.
I don't anticipate any problems, but God forbid there is, we'll deal with that, okay? I just want you guys to look out for one another, yourselves. Be safe. You have the authority to stop whatever it is you feel that's necessary and communicate that amongst yourselves and us, please.
If anything should go wrong, we should all meet in this corner here. Everyone's out of the building. We're all going to meet on that corner right there. If nothing should go wrong, but in the event, we all need to get out of the building, we're going to meet on that corner so we can take a head count.
Guys, I appreciate your volunteer to be down there. I know this, everybody wants to work, but this isn't an easy one, okay?
I appreciate it too. Let's pull this thing off. We got a lot of eyes on us today, okay? You all know this is the biggest air handler that's ever been built, a modular like this, okay? So let's have a good, safe lift. Get her done.
There is no comparison for another project. We've nothing of this size. Normally we don't use two cranes to do any job. This job is unique in every aspect. No unit this size. We've never even seen anything this big before.
What's unique about this is we're putting up 207 foot of luffing jib, which allows the crane to luff up and down. The arms back there, the transformers as you guys call it, actually is what they call a Y-guy system. And actually, once they boom it up in the air, those two arms will actually widen out and it'll make the boom stiff. So you won't have any deflection. It adds to the capacity of the crane. And we're going to be handling 15, 16,000 pound units. And the crane's got enough capacity in to allow for where one wants a safety factor these days. So we're running on about a 22% safety factor to do the hoisting.
Well, number one, the helicopter wouldn't be able to pick the weights that we were talking about lifting. It was just exceeded any capabilities. Plus the fact this flat roof sits next to the church tower and steeple, which rises up another 150 feet or so above this 22-story flat roof. Because of the proximity of this portion of the building to where we were lifting, the helicopter blades would be running into that portion of the building. It just would not have worked.
Well, we were hired directly by the crane company, Stevenson Crane, and our role in this has evolved. A couple of years ago, there was a crane accident here in Chicago where a crane actually broke through a vaulted portion of a street, and so to avoid that happening, Stevenson has adopted this as a best practice, and they've hired our firm to come through, provide these types of subsurface imaging services, and then we provide a report and we help position the crane to avoid any type of damage to the infrastructure or to the crane itself and make sure it's a safe lift. The original crane placement, we ended up moving it about 6.5 feet south of its original intended position, and that was as a result of just the proximity to some of the vaults, particularly the two ComEd vaults and the one AT&T vault.
For being on one of the largest cranes in the Midwest, all I could just say is, and not being sarcastic by no means, it's not a job for the timid.
What's happening now is we got the plenums up onto the roof, but the crane came up 5 feet short. So we had to set the plenums up on the structural steel, and then we had to actually winch them into place.
The energy recovery aspects of this particular design were centered around the fan system. Because of the amount of air that we're moving, over 235,000 cubic feet per minute of air, we wanted to be able to adjust the airflow when needed, when the building wasn't occupied or under what we call part load capacity, so that we don't need to use up all this energy in fan horsepower to deliver it through the building itself.
Part of sustainability for Chicago Temple, as far as Chicago Temple is concerned, is not just about being energy efficient. A lot of people are focused when they think of LEED or sustainability, they really kind of focus on the energy savings. In the case of Chicago Temple or any existing building, a building we're trying to preserve, the greatest sustainability that we can provide is actually to keep the building. All the energy that's made into the concrete or the rebar and putting that building together has been spent. We don't need to tear it down and do it again and use all that energy. Reactivating it, bringing it up to today's needs is really the greatest sustainable part of the project.
The Chicago Temple project and the solutions that have been developed for the HVAC system, I think, form a good template for other buildings that we could follow the same approach on in the future. Chicago itself has really embraced the green approach to buildings in a very strong and unique way, and I think that the response that we've developed for the Chicago Temple building really meets all of those requirements. But there's no reason why this approach couldn't be used on a lot of other buildings. The basic premise of this approach could be used very easily in a lot of buildings that I can think of.
The last lift was perfect. You couldn't ask any better.
We had a little bit issue with trucking coming in through the wrong street, traveling down the wrong way. They came down Clark Street instead of coming down Washington Street. The other issues that we had were once we got to the second deck, the deck was coarse. The first floor ceiling had like a corrosion layer on it, and it made everything much more difficult to move. So we had to grease everything with Joy laundry detergent to slide the pieces across the roof sections to get them in place.
The last lift was perfect. You couldn't ask any better, but the way you start is usually the way you finish, and this job started perfectly and it ended perfectly. You couldn't ask for any better.
When you take on a job like this, you've got, certain people that I'm responsible to. I'm responsible to the Chicago Temple, which is my customer. I'm responsible to the architect and the engineer. And number one, we've got to convey to them that we've got the wherewithal to pull something like this off. I am just part of the team that I put together. We had sheet metal worker, our superintendent, and our foreman was involved in this. He probably took the lead for the actual field work because it was a sheet metal operation.
We had a lot of good guys on the crew. That was probably the most significant thing that made the job go along. And then the planning. I mean, it was a complete company effort, from trucking to our safety to our superintendent to manpower. I mean, everything.
The job went really pretty much well as planned. We were extremely happy that nobody got hurt. This was a very, very difficult location to work in. I mean, we didn't even use a Band-Aid on the job. We allowed basically an hour per trip on this crane for, just under 30 pieces. And I say we pulled it off in 26 hours. Came off pretty darn close to what was planned. I believe the overriding concerns we had was getting the job in the allotted time. The cost for the crane, the people, and everything that. When the time clock was running for the 25 hours that Hill was actually lifting on the site, we were expensing about $35,000 an hour. It was just, a total team effort. We got the necessary people here. We have the people here that have done it before, and that's why it came off, the way it did.
We're very glad and fortunate that the project went through smoothly. There were probably a number of things that could have gone wrong, weather probably being one of the main issues and concerns. You can never predict that, but luckily everything went through smoothly on that end. I was very confident from the beginning of the project, having a mechanical contractor such as Hill Mechanical involved. They are one of the most respected and sharpest contractors in the local area. So I was very confident that they would take care of everything that needed to get done.
I think most of the guys, you know, I kind of look at this, it's a challenge, but it's fun, you know. If it wasn't fun, I don't think I'd be doing it.
Everything was fine. It couldn't get no better, but it all has to do with planning. It all has to do with planning, and this job just went perfect. This is what you asked for.
Yesterday morning, early as I was sitting at the computer in our study up in our house in the steeple, I saw a gigantic metal structure float past the window. It was the first of 29 sections of the new heating air conditioning tower that was being lifted 400 feet from Clark Street by that huge crane that now lies out there on the street, to be constructed on the flat part of the roof that's 22 stories up. Now, just this morning, the construction folks have given me my hard hat, which means two things. They gave it to me this morning when the work was done, because they did not want me anywhere near the work while it was happening. And the other is Pentecost. It's red. It's the only Sunday we have red, and so I want to thank them very much for being so liturgically sensitive. But it represents an enormous task that was performed expertly by 3 shifts of workers trading off 8 hours each. And truthfully, they had my prayers the whole time. It's dangerous work up there. Even being cinched to something so if they fell, they wouldn't fall all the way. Precise work as they're crawling around these huge structures. All those pieces actually fit together as a gigantic puzzle. They really had just one chance to get it right, you know. I trust they did. When somebody plugs it in and turns it on, we'll know for sure. But a new heating and cooling unit was necessary. The old one was almost 50 years old. Now, first and obviously, how we care for our church building is a stewardship matter. Now, yes, the church is not a building, it's the people. The Chicago Temple is the 5th building of this congregation at the corner of Clark and Washington. So buildings have come and gone since the 1830s, and the people have stayed anchored here. But the truth is that our invitation to the world, as we sit here in the heart of a vibrant city, is first extended by what people see. A stately, cared for, functioning, multi-purpose structure of wondrous ingenuity. And the respect we show the building is part of the reverence that we show God. Our ecological commitment to preserve God's world looks very different in the cityscape than it does in the countryside. And our focus here must be on reducing energy consumption, lowering carbon emissions, and reducing noise pollution. Now, I admit, those concerns do not sing as sweetly as birds and flowers, but they are every bit as real. So our new heating and air conditioning system, when it goes online, will be one of the greenest possible. When we do the most ecologically responsible thing, and at the same time extend the life of our structure and eventually save money, we are being faithful. So when the crane is fully dismantled tonight and taken away, just know that a lot of people would have put in 48 hours of highly concentrated work, the result of over a year's planning. We give thanks for their vision, for their skill, and for their determination. And when the time comes that we can flip a switch for cool air in the summer and heat in the winter, we will be giving thanks for the privilege of gathering in this wonderful rendering of God's house.
Country boy, his X factor. It ain't how we roll that gets you where you want to go. It ain't the horse, it ain't the barn, coming back.